Hey, it's Joel, and boy, do I have a treat for you. This is the Vision Miner 22 IDEX V3, and it is a beast of a machine. Before we get going though, of course, welcome to 3D Printing Nerd Studios, proudly powered by PCBWay, 8% off, link in the description. You know what to do. I've got this handy dandy piece of cardboard here with all my notes, so I'm not gonna get anything wrong.
Yeah, okay.
This is the 22 IDEX V3 from the folks at Vision Miner. Now I'm gonna go through some stats real quick on the machine because they're beyond impressive. 350 by 350 by 450 on Z or Z. It is an IDEX system, so there's two heads within that print volume. LGX Pro high-temp dual gear extruders on both heads, as well as slice Copperhead hot ends. Now those hot ends, those slice Copperhead hot ends on this machine are gonna go to 500 degrees Celsius plus. There's always that little wiggle room, but if you need to go to 500 degrees Celsius, this can do it. The bed though is carbon fiber. It's a carbon fiber bed and both of the heads print to it, and that bed is rated to 200 degrees Celsius. And when I say that, it's crazy. And then Rob at Vision Miner says, oh, but don't worry, it'll go to 300 C if you need it. You could actually easily cook a steak dinner on this build plate. The chamber itself has an active convection heater, and it will go to 100 C, though in testing I did push 110 C and it did not complain. Leveling is done with a switch, a mechanical switch. And the reason that it uses that is because within high-temp 3D printing, where we're dealing with a bed at 200 C and a chamber at 100 C and a nozzle nearly at 500 C, an inductive probe and a BL Touch, all of those can be a little bit sensitive to that. If we take ourselves a mechanical switch and use that to do initial leveling on the build plate, we're good to go.
Genius. Let's do this.
The materials that this thing can print, all of them, like all of them. I don't know of a 3D printing material that this machine cannot print. Do you want carbon fiber materials? Yes. Glass-filled materials? Yes. Stuff you have to, go to hundreds of degrees Celsius to print? Yes, yes, and yes. It'll print nearly everything that you throw at it. There's probably materials out there that haven't even been invented yet, that once they're invented, this will print. When we talk about printing the materials though, a lot of times with these types of machines, we're dealing with a bespoke or custom slicer engine, and that's just not the case here. Vision Miner is using Prusa Slicer and provides Prusa Slicer config bundles with the machine. If you don't want to use Prusa Slicer, use any other slicer that exports G-code, and you're good to go. It's an open materials, open slicer platform. I love that. I love seeing that in a machine that has this level of performance. Vision Miner is a company here in the United States, and so their support and service is based out of their headquarters here in the US. The reason the printer is on this table and not on my big bench is because it weighs 200 pounds. It's 200 pounds. It's a beast. And so it stays on this table. In fact, Rob from Vision Miner came here with his dad, lovely people, and helped me get it out of a crate and unboxed and set up and all of that. It was fantastic to have Rob in studio and learn from him about the machine as we're taking it out of the crate and unwrapping it and getting it going. That was an invaluable experience. From my talks with them and my interactions with them, they are very customer forward. I'm really thankful that I had that opportunity to have Rob come here and help set it up and get me going, and that made a whole lot of difference. So originally when Rob came to town and brought this little machine with him, we were gonna print with some glass-filled PEEK, but UPS decided to not bring things on the scheduled date. I was trying to think, well, what else can we throw at this thing? And I thought, I have this new Xeon material from Nexa 3D. What if we throw that in there? Nexa 3D released Xeon not that long ago because it's a competitor to the Markforged Onyx material. It's meant to have similar, if not better, mechanical properties for not as much money, which I love that sort of industrial development. And so what I did, 300 C on the nozzle, 90 C on the bed, and it's perfect. this random material that the machine has never printed with before. I gave it settings that I thought would work. I made a very educated guess at this, and we printed it. In fact, we went to lunch while I was printing, and then when we came back, we looked at it. It's perfect. Everything spins like it's supposed to. The Nexa 3D Zion is the first material I printed on this machine. This is a success.
Nailed it.
In fact, this is a really good idea. Why don't I just go through the various materials that I was able to put through this machine and show you the results. The model that I chose is the print-in-place C-clamp from Clockspring 3D. And the reason I chose that model is because it's not necessarily the most torturous 3D print, but it represents a print-in-place mechanism with some tricky angles that I think aren't necessarily the easiest when we go to higher temperature materials. With PLA, of course it's going to work, hopefully, but with higher temp materials, it can get a little squirrely. And it's not a part that you would print in that orientation in the high temp materials, but it's a really cool use case, trying to show you if it's possible. Let's go down that route. And first up is PLA. Now, the PLA at first didn't work. Go figure. Both the black, the Prusament Galaxy Black, and the High Five Blue, they seem to fuse at that print-in-place point. Let's see, I did 240C on the nozzle, 70C on the bed. So the first print was a failure, and the reason was because of the nozzle alignment. Now, the machine is able to do automatic nozzle alignment, and what I didn't realize at the time was I had done a nozzle replacement on one of the heads, so the alignment wasn't perfect compared to the offset it had computed. So I printed it again, and sure enough, they work great. I knew PLA was going to be slightly easy, and so that's why I used the IDEX system to use two different PLA variants, the Prusament and the High Five Blue, and just did each piece in each, and they look great, they work out, and so PLA, of course, passes. So next up, I wanted to try some PCBWay from Polymaker. And ABS and both polycarbonate are materials that you need a little bit of extra heat to go in. A lot of times, an enclosed chamber helps, a heated chamber helps as well. So I thought this is a perfect use case for this material. And for this material, I used 285C on the nozzle, 110C on the bed, and I just picked the ABS settings from the Prusa slicer pre-sliced configurations that they have. It's a fantastic success. This works great. And this is just using the ABS settings that Vision Miner included with the machine. And so I'm not sure if it's printed the Polymaker PCBWay before, but I know it can, and it does a fantastic job. So PCBWay, that's a pass. Now I thought I would try some PSU. And this PSU I had is years old. Like, this was back in the days when Vision Miner sent the Intampsys machine, and I had it in my garage. In order to prepare it, I set the bed to 200C and the chamber to 100C, and I left the spools in there over a weekend. That heated them up quite a bit. And then I brought them over to a vacuum chamber that Rob had sent. And that's going to draw out any last bit of moisture that's in that material. And I thought, this is what I was going to do. This years old material, maybe it'll work. And so for the PSU, I did 390C on the nozzle, 160C on the bed, and 100C on the chamber. And unfortunately, it is fused. It's fused right there. It's not fused by much, but it is fused. And there's a slight layer shift. Something didn't go right during the print process. And I wasn't sure if the PSU I had was good anymore. And so I've got a message in to Vision Miner to find out more about that. But I bet if I spent some more time with it, I could get it going pretty well. And so for PSU, it is a failure, but there's hope for the future. Next is PEI. I had two different spools of it. So I had the old Vision Miner Intampsys spool that was sent back when I had the Intampsys machine in my garage. And I also had from Rob recently a 3DX Tech spool of their PEI. Now, both of these PEIs are the 9085s. That's the formulation of PEI that's being used. And when I went to print, I chose the old spool, and it didn't look very good. And I went to the new spool, and it also didn't look very good. And so I reached out to Rob and I wanted some help with being able to print PEI. He recognized the settings that I used that they had in the config bundle, and he realized, oh crap, we have settings for PEI 1010 in there, not 9085. Because of my work, then they were able to augment the Prusa Slicer config bundle and then separate those settings. So there's now a PEI 9085 setting and a PEI 1010 setting.
Nice work.
These were printed with the PEI setting that was found to be 1010, even though it's 9085, and that was 430C on the nozzle, 180C on the bed, and 100C on the chamber. You can tell that that's too hot for this material just because of how blobby it is and how stringy it is. And so then Rob said, no, for 9085, we need to change that up a bit. So 9085, we're gonna use 385C on the nozzle, 180C on the bed, and 100 in the chamber. So we're bringing that nozzle temperature down another 45 degrees Celsius. And look at that, we're closer. We're so close. It's still not breaking free, and right where the print in place mechanism is, it's fused. It's fused. I thought, okay, let's try this again. Let's reduce the perimeters and let's have it go just a little bit faster. Have a little bit faster. And then, sure enough, we get something that works. This is PEI, Ultim 9085. And I mean, the undersides aren't the prettiest, but there's no layer shifts. The print quality is decent, and the print in place mechanism works. One of the things I do have to call out, and something that Rob did mention, is this sort of model would never be printed in the orientation that I'm printing these in, because that's not a way to imbue the model with the proper strength of material that you're using. So again, it's a torturous test, but it's really cool to see, and it's pretty strong. Like, for PEI, that's a pass. Last but not least, we're going to talk about glass-filled PEEK. PEEK itself is an incredible material. When you add some glass to it, some glass fibers, it's going to be strong and it's going to be incredibly stiff. And Rob brought this gear with him that was printed in glass-filled PEEK, and he said this is a really cool example because its resistance to chemicals is great, and you can use it in applications where a metal gear might not be appropriate. Like if you were, as an example, had gearing in a bath of acid, as you would, you could use a glass-filled PEEK gear rather than a metal gear which would erode. This would not. Sweet, and UPS finally showed up with the spool of glass-filled PEEK. And so after Rob had went home, I was like, all right, I get to do this. Glass-filled PEEK from 3DX Tech. We're looking at 350C on the nozzle, 180C on the bed, and 100 on the chamber. And that is what I made in glass-filled PEEK.
It's alive.
To its credit, the machine was doing great until it wasn't. And this is a bed adhesion issue. And this is cool because in high-temp 3D printing, bed adhesion issues are not good. They're not good. And throwing brims and solvents or glues or whatever you want in the bed is absolutely fair game, because a spool of glass-filled PEEK can cost anywhere from $600 to $800 US. So when we look at a failure like this, it adds up rather quickly. It's imperative that you do the proper bed prep technique, and Vision Miner has their nanopolymer adhesive. It's one of the adhesives that we helped them launch back in the day and did this giveaway. It was amazing, and since then it's been an essential part of the 3D printing community for just bed adhesion with general polymers. But what's great is using high temp polymers, that's where it really shines. And so what I did is add some Vision Miner's nanopolymer adhesive to the part of the bed where I was printing this. And there are ways of applying and temperatures that work out great that I learned from Vision Miner support. And high temp printing is still completely foreign to most of us, including me. But I'm learning, which means you get to learn as well. So I applied the nanopolymer adhesive to the proper part of the bed using the proper temperature and the proper brush technique. And then I printed some glass-filled PEEK. And it works. It absolutely works. Yeah! And it is strong. This is probably one of the strongest prints I've ever printed. And it's a print-in-place clamp printed at an odd orientation just to showcase that this machine can do it. Glass-filled peak. That's a success. Vision Miner has been an incredible asset to the 3D printing community, and they've been really fun to work with. I'm really glad that I've met Pat and Rob and the others there, and they're not just co-workers in a space, they've become my friends. I think that they're operating their business with the right mindset in that they're trying to build an incredible product and get it to the people that need it. And then once it's there, they're trying to help their customers as much as possible. Rob was telling me about the times when customers call in and they have a difficult part and they want to print it in an exotic material. And Vision Miner will do the legwork to make sure that they're orienting their part correct and they're putting the right amount of perimeters, the type of infill, the top and bottom layers to make sure that that customer sees some success with their part using an exotic material. And in doing that customer education, now that customer is empowered to do all sorts of really cool printing. That's thanks to Vision Miner's vision. And I'm really thankful for that. Now that you know what this machine can print with, just know it's really expensive. Like, it's not for you and me in our garage, it's for businesses to use. But those businesses are really happy that this exists because for the longest time, being able to print glass-filled peak or Ultim or PEI or PPS or high-temp nylons, those were machines that cost sometimes six figures. And to have this machine now at its price point is, I think, valuable for the industry. And so in that time that I have it, I do have access to some really cool materials, and I'd love to know what you want to see printed on this in exotic high-temp materials, because I can make that happen. Well, listen, thanks for making it this far. If you did, you're awesome. Don't forget to hug each other more, fight for a cause you believe in, and high-temp print all the things. And as always, high five.